We are the Light Energy Visualizer team. And for our project, our goal was to measure the amount of light energy hitting infants during phototherapy. Currently, light energy hits an infant based on the number of lights that are prescribed by a doctor in order to treat jaundice. Jaundice is a condition of too much bilirubin in an infant's bloodstream. Most adults process bilirubin all the time and it's not an issue. Yet when an infant is newly born, they don't always have the ability to fully process the bilirubin that's generated in their body. In order to aid this process, doctors can apply 400 to 500 nanometer light to an infant in order to speed up the process through the absorption of light into the skin and bloodstream, which then transforms the bilirubin particles into something that's more easily excretable. Currently, light is only prescribed on a 1, 2, 3, 4 lights, floodlight, spotlight basis. Very inconsistent. Therefore, for our project, our goal was to quantify the exact amount of light energy hitting an infant during phototherapy. In order to do this, we had a couple different approaches. One was to put some sort of suit or blanket on the infant that would have numerous sensors on it in order to measure light energy at a bunch of different points. The second one was to figure out the amount of light energy coming from the lights and overall, and then where the infant is relative to the lights, and deduce the light energy hitting the infants that way. The third way was to take a total light reading of the area where the infant was lying in the crib, and then subtract the amount of energy hitting the infant from that. We decided to go with the third approach because we found it to be the most robust in order to suit a variety of different infants and sizes, and also a variety of different cribs. Therefore, we designed a scanner to measure light energy. The process: first, the infant is taken out of the crib and the scanner is placed into the crib with the lights on in order to treat jaundice, so the phototherapy lights are turned on. Then a scan is taken of the crib in order to gather the total light energy hitting the surface of the crib. The infant is then placed on top of the clear cover on the scanner, and another scan is taken. Between the two scans, there's going to be a difference in light energy. The difference is the amount of light energy that is absorbed by the infant. Therefore, the scanner can then be taken out of the crib and the infant placed back in the same location, and we have a precise measure of how much light energy the infant is absorbing from phototherapy. This is important because too much light energy absorbed during phototherapy could lead to skin complications as worse as skin cancer in years down the road. Our system has three main components. The first is the 80-20 aluminum frame with the clear acrylic cover. The second is the two-stepper motors and stainless steel all-thread rods, which then drive the third component, which is our sensor bar, which has guides in the 80-20 along the sides, and is connected to both drive shafts in order to move smoothly from one end to the other of our scanner. The scanner bar itself contains 18 sensors at 1-inch increments in order to get effectively an 18-inch by 24-inch grid of light readings. These are then processed by a Raspberry Pi and displayed in a graphical and numeric form for easy interpretation of both location of high-intensity light and total light energy over the whole scanner area, and then the difference between that and when the infant is placed on the scanner. I think I just stole. In conclusion, our system should enable medical professionals both to research the exact ratio of light energy hitting an infant and bilirubin treatment and reduction levels, and also provide the ability for medical professionals to more evenly spread out the light treatment that is hitting current infants in phototherapy in order to avoid hotspots. This is significant because it reduces the potential for skin damage and other skin-related illnesses in infants' futures, and it also allows more precision in the medical field. Thank you.